Good afternoon, everyone. If I could ask you to take your seats, we'll move ahead. Welcome to this session on reducing carbon footprint of existing campus buildings. As we know, we all have a lot of built space, and even though we're building new space all the time, we have old space, space that may be as much as a couple hundred years old that we're continuing to use. Figuring out how to reduce the carbon footprint of the space we have and the case space we're going to continue to use is absolutely critical to us ever reaching our goals of zero carbon. I'm Sherry Ton, Vice President of Finance and Operations at Pacific Lutheran University, and I'm also the chair of the board of the Association for the Advancement of Sustainability in Higher Education, one of the supporting organizations for the President's climate commitment. First of all, I'd like to talk a little bit about logistics, and then we'll move to our panel. At each table, there's a computer, and on that computer, you have the ability to enter questions for the panel. So as we're going through these presentations, I'd like to invite you to enter those questions. There's probably someone sitting in front of the computer, and that person can be the typist, and there are tablets on your tables. We just saw some people move. There are tablets on your table so you can pass notes to that individual. Now, they can't cruise the web. All they can do is answer those type in those questions and hit submit, because when you hit submit, it will go to our panel up here and they will aggregate the questions for us for later in the panel. Please feel free to hit submit as many times as you'd like, with as many questions as you'd like. Later on, we'll move to some discussion topics that you'll discuss in small groups at your table, and we'll likewise submit the results to our theme team, which is up here waiting anxiously for results to be submitted. We'll gather those, and then for the last 20 minutes or so of this session, we'll talk about those gems that were found during the process of your discussion. We'll work on the questions that you've submitted during our panelist presentations and try and come up with some themes as an outcome from this group. Now I'd like to introduce our panelists. We have 4 panelists today, and I'm going to introduce all 4, and then they'll get up sequentially to do their presentations. Our first panelist is Larry Eisenberg. He's the Director of Facilities Planning and Development at the Los Angeles Community College District. That district has about 9 campuses, 6 million built square feet, and 188,000 students. The other description of the panelists are listed in your program, so I'm not going to go through those right now. I'll leave those for you to read later on. Second panelist is Jonathan Magaziner. He's the program manager and analyst for the Clinton Climate Initiative. He's going to talk a little bit about the building retrofit program that the Clinton Climate Initiative has and initiatives among various colleges and universities. Our third panelist is Ed Popple, who is the Vice President of Business Affairs at the University of Florida. University of Florida is a university which provides an example for which we can all learn with the great progress they're making on their over 22 million square feet of built space. And our fourth panelist is Thomas Kaiser. He's the founder of Professional Supply Incorporated, and he brings together the idea of energy purchased with the energy you need for operating your campus, and has been working with Arizona State University with its over 20 million square feet of built space. So first panelist is Larry Eisenberg. So please feel free to work on your questions as you hear our panelists speak.
Thank you, Sherry. It's a pleasure to be here. I could speak for a long time about this, but I'm going to just launch right in and try and give you a nutshell of what we have going on at LACCD. In 2002, our Board of Trustees adopted a sustainable building policy. You see in the little booklet that we're running a program of $2.2 billion now. We have another ballot issue coming up, and if the voters are kind to us, we will have $3.5 billion more in November. All of that will be used to build sustainable buildings. We're building 44 buildings now. And they also adopted an energy policy that called at the time for a modest 10% of alternative energy to be used on the buildings, with an attempt to get to 25%. That was 2002. I came in 2003, looked at what we had going on, hired a lot of really bright people because I had a lot of money, and we've developed a policy that is leading us to, at the end of this year, to be entirely 100% alternate energy. All colleges, we will be off the grid 24/7. We're doing that in 3 ways. We're doing that by installing renewable central plants that use primarily solar, thermal, and geothermal as their energy source. We are doing a major energy conservation effort on our existing buildings. We have 455 existing buildings. We're working with Jonathan and the CCI to do that using the CCI model to make that happen. So we will retrofit every building that we have by sticking new things in, taking old things out, and putting things in like occupancy sensors and metering and measuring kind of devices, changing out lights, which you've already done, but technology is changing radically. So that's going on as well, using, again, the CCI model to make that happen. And the last part is the idea of doing alternate energy using solar in terms of carports and rooftop application. For the solar generation capability, we're using architectural scale wind generation, not the big 3-bladed towers, but there's new technology out that allows you to put things on the roof of buildings, on the edge of buildings, that generate a significant amount of electricity. And then using ground source geothermal. This is not the volcanic geothermal. Basically just drill down 20 feet, soil's 50 degrees, the temperature differential can be captured as energy. So that's the plan we have in place. We're starting construction now. We have 3 megawatts of photovoltaic in place generating energy, already saving us money. To make this all work, we needed to deal with energy storage. Do not believe the idea that there are not good batteries out there. They're not the kind of batteries you think of. It's not little Energizer. It's not lead acid. Basically, we are using our energy generation capability, using old high school chemistry, while electrolyzing water to make hydrogen. We store the hydrogen. We put it in a fuel cell at nighttime, and it makes energy for us to do that. That's one very effective way of storing energy. So, because for us, community college, our peak enrollment, peak energy demand is 7 p.m. at night, and fortunately or unfortunately, the sun isn't there all the time at 7 p.m., even in LA. So we need to carry the energy from the daytime into the nighttime to make that work. So energy storage is key to making that happen. It's part of the technology and hardware we're installing to make that happen. The last part of the equation was the cost side, that although I have $2.2 billion when I came, all of that money had been allocated to build really nice things like science buildings, libraries, and classrooms. So to deal with the energy side, I had no money. So we're doing what I just described to you with no capital investment. We're doing that through performance contracting for the energy conservation elements to make that happen, and we are using a power purchase agreement methodology to put in the alternate energy. We're having a third party do that, so private firms like Johnson, Honeywell, those kind of guys, they can use the federal tax credits, they can use rapid depreciation, they get the local incentives from the utility companies, they can sell the RECs, or we could sell the RECs if we want to make that happen. We cover 90% of the cost that way. The last 10% we cover through a power purchase agreement. That power purchase agreement provides that we buy every single kilowatt the system makes. Our first power purchase agreement cost us, in LA context, 13 cents a kilowatt. That compares to what we were paying the day before of 21 cents a kilowatt. So it saved us about a third of our cost. I spend $12 million a year on energy, about $1 million a campus, and a little bit different other places. So basically, at the end, when all is said and done, if my next bond issue passes, we have money in to buy out that last 10%, then we will have no energy bill, at that point in time. That money we can use to hire professors, maintenance guys, do whatever we need to do, but not spend it on energy. Thank you.
Hello, my name is Jonathan Magaziner with the Clinton Climate Initiative. I'm working on managing with our building retrofit program in the education sector, among other things, partnering with Second Nature, and Andrea Putman in particular has been co-managing this with me. We can start the slideshow and I'll describe a little bit about the building retrofit program. Well, first, with CCI in general, we're active in a number of areas. We began our work about a year ago through a partnership with the C40, which is a consortium of 40 large cities across 6 continents, 40 of the largest cities in the world. And we're working in the areas on the left there. Those are our various programs, from buildings, waste management, transportation, clean energy, all the way down to a developing countries initiative, which has a particular emphasis on forestry. But our partnerships have since expanded beyond the C40 to include other groups like the U.S. Conference of Mayors and the American College and University President's Climate Commitment. So to start with buildings, why did we create the Building Retrofit Program, which is currently the program that has been in existence for the longest period of time? Well, globally, it's a large source of greenhouse gas emissions when you think about end use, 40% of GHG emissions globally, and it could be about 75% of emissions on college campuses and in large cities. One surprising statistic is in New York City, buildings can account for about as much as 85% or more of the greenhouse gases in the city, which is far more than transportation. And that usually the first guess of everybody is transportation in New York. And we believe that the way we conceptualize it, there's excess energy and savings that are just trapped in existing buildings that can be released through simple retrofitting of technologies and rationalization of systems. Existing buildings also tend to use 25% more energy than new buildings, so they require I think a degree of attention that has not been afforded to them recently. A lot of attention is on new construction, which is all well and good, but existing buildings are a greater source of the problem. And from a cost perspective, if you look at that pie chart on the right, about 3/4 of the life cycle costs of a building occur after construction is completed, which is a surprising statistic to a lot of people, which essentially means that if you're looking to get some cost savings and try to justify a retrofit project economically, that should be fairly easy to do. If you reduce the energy costs and ongoing operations and maintenance costs in a building through conducting a retrofit, you can reduce the life cycle cost of that building substantially. And the last point there is that efficiency is always a good first step. A lot of people get excited about when they think climate neutrality, they think of offsets, they think of on-site renewable generation, and both of those things have to be done if you're going to truly become carbon neutral, no question about it. But efficiency is often the best step for a couple of reasons. One, it creates money that you can therefore invest in some of those other areas. When you reduce your utility bills, your O&M costs, that's freeing up cash to put forward to other efforts. And two, from a physical perspective, you don't want to create a renewable energy system that is bigger than it has to be. You don't want to spend that extra money. So make your building as efficient as it can be, and then your cost for installing a new renewable energy system will go down because it will most likely be smaller. Next. The particular vehicle that we've adopted to promote building retrofits and energy savings is performance contracting, which is a contracting model that has been in existence for some time, but we're trying to catalyze the market and streamline the process and provide some quality control for performance contracting that hasn't existed before. Essentially, the way performance contracting works is that an energy service company, or ESCO, conducts an energy audit, targets various energy conservation measures, or ECMs, which can include things like lighting retrofits or improving the efficiency of a steam distribution system, and it could go on. And then they calculate the cost of each individual retrofit and what the savings over time can be for those retrofits once you install new equipment or rationalize the system, make it more efficient. Then the energy service company becomes a general contractor for implementing all of those retrofits. and guarantees that the annual energy savings from those retrofits during the contract term will equal or exceed the annual cost that you have to pay for those retrofits. So normally the way it works is that there will be a third-party lender, at least under our model, that provides 100% of the upfront capital cost for the project, and then you pay debt service over time each year. Well, the guaranteed energy savings are guaranteed to equal or exceed the annual debt service payment. So it's a cash neutral proposition, over the course of the term. And the graph up there on the right can sort of help you visualize the way that model works. We can go to the next slide. I realize I'm short on time. So to implement this program, we've partnered with a number of the largest energy service companies in the world, some of whom are represented here today and are sponsoring the conference, actually. In our agreements with them, we've signed some memorandum of understanding, and they essentially ensure that best practice terms and conditions for the contracts will be available to all of our partners. We're going to reduce program costs for the way that these ESCOs do business, which will ultimately free up more opportunity to create deeper savings. And we're going to help guide institutions along the procurement process to ensure that their goals and financial criteria are met. We've also partnered with 6 large financial institutions who are agreeing to provide 100% upfront capital for the project, so there's no capital cost up front the way Larry Eisenberg described. And they're also going to be available to provide efficient access to capital where there are areas, if an institution is particularly having some difficulties acquiring that capital. Next slide. And then the third component of the retrofit program, in addition to the ESCOs and the financial partners, is a purchasing alliance we've organized, which is essentially harnessing the buying power of the 40 largest cities in the world, 500-plus colleges and universities, and a number of our other partners in the U.S. Conference of Mayors, et cetera, to reduce the price by encouraging. We've signed agreements with these companies, just to put it simply, to reduce their prices in return for expanding their volume, by expanding their customer base. And we've negotiated 25 supplier agreements to date. You can see some of our partners there on the right. And the reductions range between about 25 to 70% for more niche, high-efficiency items, and for some of the commodity items, like the lighting equipment especially, the discounts are a little bit lower, around about 5 to 15%. And so with the ACU-PCC, the way we're rolling this program out, and this is my last slide, so I'll be brief. We're starting with a group of schools with which we're working very closely to learn from them and to implement our model in a very hands-on way to figure out, precisely how and in what ways can CCI add value to the process. And as we're doing this, we're developing what we're calling a toolkit for performance contracting, which is going to rationalize the decision-making process that an institution has to go through to contract with an ESCO. That's going to provide guidelines and some boilerplate documents that can help streamline the process and harmonize it, reducing program costs. And then ultimately, after this toolkit is released, we're going to facilitate a network of support across a number of institutions with the support of some CCI staff and some consultants with which we're working to provide ongoing guidance to the schools that want to engage in this process. So that's the CCI Building Retrofit Program and our partnership with the ACU-PCC in a nutshell. I realize there's a lot of information for a short period of time, and I went over my time, and I apologize, but I'm happy to answer all of your questions later. Thank you.
Good afternoon, and greetings from the University of Florida, home of the Florida Fighting Gators. The University of Florida operates like a small city with high-voltage electrical transmission lines, one of the largest connected load chiller water systems in the country, a cogeneration plant to produce steam, and a state-of-the-art water reclamation facility. On our main campus, we have 52,000 students, 25,000 employees, located on 2,000 acres with over 20 million square feet of building space. Next slide. This is a snapshot of our greenhouse gas footprint for 2007. As you can see, the majority of our footprint comes from electrical use on campus. About 60% of that electricity is used to run our systems. About 40% is in the hands of our students and employees. The average temperature in Gainesville is near 80 degrees, and the average daily humidity is 74%. So our primary challenge is not just cooling our buildings, but conditioning them. For this, we run a chill water loop through campus, operating 10 major chiller plants. Next slide. We continuously focus on decreasing utility consumption and improving system efficiencies. For electrical consumption, we have already converted to efficient lighting and are constantly testing new technologies such as LED, induction, and new fluorescent technologies. For chill water and steam, recommissioning as well as continuous commissioning aid in lowering building demand. As we decrease demand on the chiller plants, we also focus on increasing plant efficiency with variable frequency drives on chillers, thermal storage, and different operating sequences. The majority of our reclaimed wastewater is used to irrigate and are converted to steam. We're continuously trying new waterless devices to reduce water consumption. The top pie graph in our greenhouse gas footprint we looked at in the previous slide. The bottom is a snapshot of our annual utility bill. Not only does electricity comprise 60% of our greenhouse gas footprint, it also comprises 80% of our $46 million annual utility bill. We have a lot to gain both financially and toward our climate neutrality goal by reducing the use of electricity. Next slide. We have opportunities to build new buildings to higher energy efficiency standards through our LEED commitment. Our current LEED standard is silver for all new construction. We also have opportunities to make our existing systems and square footage more efficient. We've got 32 buildings in our LEED EV portfolio. As part of our climate action plan, we will conduct a year-long assessment of our physical plant, taking a complete inventory of our windows, air handlers, roofs, lighting systems, and IT servers. While many of these items exist on a very, very long deferred maintenance list today, we now need to evaluate and rank them with regard to return on investment for energy savings. We are using our main administrative building, which houses the President, my office, and other Vice President's offices, for all of our pilot programs. It's a 55-year-old building that is in a real challenge. As you may know, air handlers are built to last around 15 years. The air handlers in our building are the original, amazingly. They should be operating at 90% efficiency. They are operating at around 60% efficiency. That equivalent is a loss of 30 cents on every dollar. With energy prices on the rise, the return on investment in efficiency starts to look very attractive. Next slide. As a research university, we also have opportunities to demonstrate leading-edge technologies on campus. We've got the Florida Institute of Sustainable Energy, as well as a technology incubator. We are currently looking at several waste-to-energy opportunities that will advance both our zero waste and carbon neutrality goals. Our students initiated a 50 cents per credit hour fee recently. They want to charge themselves to raise funds for renewable energy on campus. This is the passion we see among our students to embrace sustainability. Next slide. Finally, I said in the beginning that 40% of the opportunity was in the hands of the students and employees. Behavior change campaigns are critical to our success. We've developed building dashboards to give building occupants and managers real-time feedback on building performance, empowering them to find ways to decrease the building load and alert them when systems are not functioning properly. You'll note a website on the slide that you can go to and see our online dashboards. We've developed a green team network on campus, identifying captains in colleges, departments, and units who can spearhead energy saving and other sustainability initiatives. We hope that developing the common sense practices for reducing energy on campus will translate to our employees and students that will adopt these same behaviors at home. Thank you.
Good afternoon. My name is Tom Kaiser, and I got 5 minutes to share with you a little exercise in coaching. I have met a lot of people over the years, but I'm an Ohio businessman, and I founded the business on a principle. And it's go call on people and see if you can help them. And for every $10 you save them, maybe they'll give you $1. And you could employ some skills and experts, because the mother of all skill is repetition. We started in 1980, we decided to take an approach to energy efficiency and justify everything we do on energy efficiency, much like some of these presentations have been made here before me with regards to the mission statements of ESCOs. Next. This is the business I'm in, ladies and gentlemen, and I found over the 1980s it was a very, very difficult business to be in America. As a result of going into a building and seeing every 60 seconds how much energy does the building really need versus every 60 seconds what did it just purchase through its utility meters, I started asking people questions. And in learning and discovering and studying residential, commercial, and industrial type occupancies, as well as unoccupied occupancies, I discovered that we had energy efficiency ratios of anywhere from 1/10 to 1/5 to 1/3. I found that when it got real hot outside, buildings would now and then run efficient as good as 1/3. I found that when we spent the bulk of our hours in called partial load efficiency and unoccupied, I found the buildings not able to modulate in efficiency, just try to modulate in comfort. And as I went through as an aeronautical engineer and I started to discover what we were up against in facility engineering, I started to develop and work on a principle, named the company Professional Supply, so that it would stand for a design that will be guaranteed a commissioning, and year after year will deliver the expected energy needed. So next. So the 1980s and the 1990s, this is what you run into in America. The professional engineering to the architecture of design, you run into the assumption and the belief that every unit you bought at home, you must have needed. Every ounce of gas that you used, you did get the calories from it, right? You do assume that. And you'll find that in this walk in life in America, as I found that there's a lot of old infrastructure out there still running on the steam engine. And I would ask college campuses, and I would ask facility directors, and I would ask plant engineers, can I ask you a question? I'm here in Phoenix, Arizona. It's 86 degrees outside. You've got 38,000 pounds per hour of steam firing through them pipes in 5.8 miles of underground tunnels. Who's using that energy? I'd just like to know. I don't know. Well, can you show me by building? There's 93 buildings connected to it. There's 8.2 million feet. Could I ask this question? Are you sitting there running your engine at the red light? Or is it off? So that's where we started, and we realized where we got to go with the mission. Next. In 2007, I was fortunate enough, through my activity as senior advisor in China, I was fortunate enough to come to Washington and give a debriefing, and out of the audience come a couple of people that I met and inspired me in why I like to become, and now proactive with universities. You see, you teach our future. You are the platform that's going to make the difference. The art of coaching is how good can you stand on the sideline and assist others at winning on the field. And you are on the field, ladies and gentlemen. You represent America's platforms, and with no dreams, we have no future. So I was lucky enough to meet Jim Kaiser of Arizona State and Gus Speth of Yale. And Gus said, you got to come to Yale. You got to do a study. And I naively said, no, I don't. Universities are efficient. There's no way they could be made more efficient. And thanks to Gus's persistence in seeing the value of energy efficiency, I did the study at Yale. And here's what I learned. Is it fun to work with the young people? We got the environmental and the engineering students as part of my team. We studied the campus. It was a phenomenal realization for me, the amount of emission that a university is capable of making. In fact, it was bigger and more per person and per square foot than the Ford Motor Plant that I thought was America's armpit. Next. So we introduced a protocol called Green Machine Design Intent for what we call retrofit. How do you go hybrid a building? How do you hybrid the car so that at the red light the car engine literally could turn off? Because buildings can't. They're sitting there idling, and I ask you this question. In the last 1 minute during my talk, how much energy just came through this building versus what it needs? So when you deal with the variables of occupancy, internal energy usage, Einstein taught us, you don't terminate energy once you make it. You just transform it. So we got into the business of you using energy, now we got to recycle it. Just recycle it. So we do that. And as a result, for every 3 units of energy you need, we only want you to buy 1. In taking this design approach to 25 million square feet of plants, and 6 million feet of that was classrooms, offices, locker rooms, and cafeterias. In doing that, I learned that there's a huge opportunity, thanks to Bill McDonough and Vice President Gore, sitting me down and teaching me in 1999 the impact on the environment, which you can see before you. Next. So as I was working at Yale with Gus and working at Arizona State with Jim Beiser, I got a wonderful opportunity to go in and also teach how do we navigate. How do we get after a campus and even consider hybriding? And I want to remind all of you this. We're better together than apart. The bigger your problem, the easier the solution. The bigger animal you are of being out of control, hey, that's just a more leverage for the solution to be implemented. So as I get into the energy efficiency analysis and I get into it with the students, yes, we are in the process of designing now a curriculum at Arizona State under the direction of Michael Crow that will enable the students to actually execute this kind of work as a curriculum. It's time we teach America's future, and the people that are really skilled at teaching and communicating the raw, hard data facts to young people are you. So you approach, for example, 100 buildings, and I just want to emphasize, isn't it cool? You take 100 buildings and you want to go hybrid them rather than rebuild them. And you want to do everything you can to meet a gold, platinum, or a silver standard. But while you're doing it, you can now leverage in real timing what we call a biopsy. In the example on the screen, there's 4 occupied buildings that need to be studied that represent the square footage of 8 million feet, 93 buildings on the Tempe campus connected to steam. In going out and getting after submetering, I want to make sure all of you understand we now live in a no-excuse world. With the power of IT and the power of wireless, we can go meter anything. There's nothing we can't verify, validate, rather than assume. And in doing that, you can now move on to real system definitions that the previous speakers have told you that can be guaranteed in the financial arm so you don't have to come up with capital. And then when you come up with these type of things, you now can have what we call installers really exercise their skills, and that's the skill of hybriding a building without disrupting the occupied business you're in of teaching. And from there comes the most important part. Does it commission and sustain itself by the people that operate it on the campus? So with that, you take the savings and you share it. You make sure that the customer wins in a reduction of operation cash flow, and you make sure the debt service, the investors win on the returns. So thank you for your attention, and look forward to your questions.
Thanks to our outstanding panelists. Now we'd like to move to some discussions at your tables. I've seen a few questions come forward to our theme team over here, and we'll get those questions in just a little bit. But in the meanwhile, here are your discussion questions. They just went away. Back to the discussion questions. You have your discussion questions on your individual computers. We're waiting for our discussion questions. You do? Great. Here they are. What are the effective strategies, including behavioral and infrastructure improvements, to reduce buildings' carbon footprint as quickly and comprehensible as possible? Give examples on your campuses is number 1. And those of you who are at even-numbered tables, 2, 4, 6, 8, etc., please start on question number 1. And the second question, what are the cultural and financial challenges of trying to make the campus-built infrastructure climate neutral, and how do you most effectively deal with these questions? And we'll start with the odd-numbered tables working on this question, 1, 3, 5, etc. When you finish that question, you can switch off, and handle the next question. Andrea Putnam is up here with her theme team working on those, and will compile your results as you enter them in your computers. So please remember to hit submit. Go to it for about 15 minutes. Thank you.